Like I am Raja Vasantan, and so I'm a founder of a company called Grits and Guides, and Each One Teach One, and Intelligent Quotient. So Grits and Guides is a service-based company where we used to build products, and Each One Teach One is a non-profitable community where we used to teach computer programming and AI in their native languages. And Intelligent Quotient is a AI-based startup which is incubated in IIT Madras. So this is a quick startup, a quick intro. So before going into multimodal RAG, first let's understand what is RAG. So RAG stands for Retrieval Augmented Generation, where we used to whenever you have a PDF document or whenever you have a proprietary document, for example, inside a company, in enterprise level companies, right, we have lots and lots of documents and lots of informations within our organization. So as an enterprise company, we don't allow these documents to go out to a LLM model to do some process, right? At the same time, the context of the documents will be very heavy, right? So we cannot feed that into a LLM model because every LLM model have a limitation of context length. So what we do is we used to chunk these documents into multiple parts, and we used to give it to the LLM model. But that is what we are doing so far. So for doing this, we have two things. One is chunking the PDF. For example, if you have a 500 page of PDF, you cannot give that whole 500 page of PDF into a LLM model, and you cannot ask any question. Like for example, let's say you have a HR policy document for 500 pages and you want to know what is the leave policy, and you cannot go and search for 500 in the 500 pages, right? So what we will do is we will give this 500 pages of PDF document to a LLM model, and we will try to get the information from that 500 pages. But the problem is each and every LLM model has the context length, so we cannot give that into a LLM model. So what we will do is we will chunk this document into small pieces, and we will convert that pieces into a vector database. So vector database is a very popular database concept which is evolving right now. So to understand vector, so let's imagine this diagram. This diagram is not a fully visualized thing, but we all know two-dimensional things, two-dimensional vectors and three-dimensional vectors. Even we can understand about four-dimensional, but beyond that, it is very difficult for a human being to visualize that dimensions. So if you take this is a 300 dimension vector space. Okay, it has a 300 dimensions of vector space. So what is vector? Like you can say that I want a office space with 500 square feet in second floor. We have only two features to search the office space. Sometimes we will be having three features. What if you have 500 features to search a particular office? So that 500 comes as a 500 dimensions of search parameters. So what we will do is we will take this each and every word and convert into a vector, and we will store that vector into a vector database, which is nothing but a numerical representation of this particular words. So if you visualize this, what happens is, if you see apple and banana will be a little bit closer, and chicken and cat will be little bit away from each other. So if you say apple, then your chances are more to get banana also, right? So this is kind of a similarity. So for example, what we can do is there is a famous example called like king minus male plus queen is equals to, king minus male plus woman is equals to queen, right? So you can do some mathematical and arithmetic operations on top of word using this vector. So what we will do is we will chunk that large document into small pieces, convert into a vector and store it in vector database. And whenever I have a query, like for example, what is my leave policy? This leave policy will also convert it into a vector, and it will be searching here. I will show another diagram. So step one, PDF is chunked into multiple small pieces. Then that chunking is going into an encoder. This encoder is a LLM model which will convert this word into vector thing, and this vector will be stored in a vector database. This is process 1. The process 2 is whenever the client is asking a query, what we'll do is we will send that query to another, again the same encoder, not a different encoder, the same encoder, and get the query as embedded, and we will compare this two vectors. There is something called a cosine similarity. Cosine similarity means like you have a lot of vector points and you have a small vector points. You need to now find the similarity between these two vectors and find the expected result. And after that, now we have the chunks, we got the chunks. Now we will send this chunk to a LLM model. It can be any LLM model. It can be open source model. It can be a paid model. And we can send this data to a LLM model and get the results out of that. Okay. So this is the concept of retrieval augmented generation, which is happening so far, right? So till this, you understand, right? Right? Yeah. Okay. So now let's come to the problem. The problem is what happens when you have that when your document have a very complex layouts, like something like similar to you have an image and you have a content, again you have a table, you have some content. There are lots and lots of layouts or the different type of layout. Now how will we do RAG on top of this document? For example, I want to ask a question from that particular image, like for example where this blood cells are going, or what is the difference between lenticular vector and AI vector. So if you want to ask any question on that image, this existing RAG system will not answer. It will answer only in text format. So what we are going to do is we are going to see how to do RAG, retrieval augmented generation, on top of this complex PDFs or documents. Okay. So this is the overall talk today. So solution is multimodal RAG. So what is multimodal RAG? We are going to include all the text, image, table, graphs, everything as a vector. So vector is nothing but a numbers. Okay, you can convert a text into a vector. You can convert image into a vector. You can convert audio into a vector, or anything into a vector, right? So vector is nothing but if any input goes, it will come as a output. That is the vectors. That is numbers. Okay. So step 1. This has multiple steps. This is not a very easy step. So it has a multiple steps. So the steps involves, like, first of all, we are going to send the PDF to Azure Document Intelligence. So we need some kind of AI system to understand the layout of the document. So what this Azure Document Intelligence will do is, this Azure Document Intelligence will analyze the layout of PDF. It says that, hey, this is the image, this is the table, and this is the content, and it will give it in a markdown format. So you all know about markdowns, right? Like .md file. So it will give it in a markdown format. So this markdown format has all the informations, as like where is the image is there, in which x and y axis the image is placed, and in which x and y axis the table is placed. All the informations will be given by Azure Document Intelligence. So once this is done, the next step is we will save each and every page as an image. If there is a 500 page, we will loop to it and we will save each and every page as an image. That will be a 500 image will be there. Okay. So now we have two things in our hand. One is the markdown. The second thing is the 500 images, right? The next thing is this document intelligence is giving a like the coordinates of the image for particular in page number 2. This is the x and y axis of the image. So what we will do is we will crop this image as a separate image and we will extract it. There is no AI involved here. This is only a normal programming concepts. So we have a x and y axis and we have an image. Just use some logic and crop the image and extract the data, right? The next thing is, now we will give this image to an AI model and ask to explain this image. So what will happen? The prompt will please give a caption about the image. This is what the prompt will be giving. The AI model will understand this image and it will give a caption. Okay, it will give a multi-line caption and we will save this caption in a separate file. So the first step is get the PDF into a markdown, then convert the pages and crop the image and send each and every cropped image to a AI model and get the captions for that particular image. So this is the fourth step. Fifth step is, now the markdown which is given by the Azure Intelligent will be like this, like it will have some markdown things. Usually markdown will have some, if you put one hash it will be a long big heading, double hash means like small heading like that, right? So it will have everything, but whenever there is an image, the Azure will give a figure tag over there, right? Now including the ID of that figure. Okay, now what we want to do is we need to replace every figure tag with the figure URL. See, if for example there is something called outputs cropped image underscore 1.png and the caption generated by the AI. So if you see this caption is generated by AI. So what we are doing, this is nothing but a regular expression. This is a kind of a regular expression thing where we identify the figure tag and replace that content with this URL. So now we have a finalized markdown file from the top to bottom for all the 500 pages, including the content, including the image, even the table, and everything is in one markdown file. So this is the thing. Now again we know that we have a long markdown file. Just split that markdown file into small chunks and it is ready to go into vector database. So in chunking there is a strategy. Okay, chunking strategy is not a one-step process. There are multiple strategies are there. So you need to trial and error which strategy works. For example, you can split the whole content line by line. That is one strategy. But if you split into one line by line, what happens is the meaning of the paragraph will be lost, right? So another strategy is you can split it by paragraph. If suppose one paragraph is very long, again the context problem will rise, right? So what happens is whenever you find a paragraph more than 5,000 words, then recursively split that into two. This is another strategy. So splitting the markdown file or splitting the files into multiple chunks is not one single strategy. You need to do a trial and error over there. There is no way okay, right? So we need to split this and make sure that whenever you split, this figure line should not be splitted. Okay, either the figure line should be going to the first chunk or it should be coming to the second chunk. For example, there is a chunking strategy called chunk the document for 1000 characters or 1000 letters. Okay, what happens is whenever we are chunking it from the top, this figure URL will be chunked in the middle. So what happens is again you will lose that whole image, right? So again we need to use a kind of a regular expression logic, regression logic, saying that if there is this particular in pattern, so we have a pattern, right? Explanatory mark in a square bracket we have a figure ID and followed by URL of the image and followed by caption in the star. So you can identify this regular expression pattern and you can write a logic. Whenever you find this pattern, don't split that pattern. Either you put it in upper chunk or lower chunk. This is what you need to do, right? Then what we will do is we will do another kind of chunking, saying that each and every chunk should be, like for example, we need to extract this figure as a separate chunk. For example, if you are splitting this document into 3, the first chunk should be the content. For example, some text here to this section content 1. The second chunk should be the image, and third chunk should be the content, and fourth chunk should be the last image. So you should not lose the information of the figure over there, so that the information will be retained, right? So this is 6 steps. 6 step is very little bit like you need to do a trial and error and all those things. Okay, so nowadays regular expression is very easy. Just use some AI model to give the pattern and ask him to write a regular expression. It will write. So there is no problem here. Okay, 7th step is again chunk. Put every chunk into a vector database and convert into store it into vector database. Convert into vector and store it into vector database. Now, when it comes to vector database, there are lots of vector database there. My like I used to use MongoDB. MongoDB is my favorite, but there are lots of vector databases are there. For example, Pinecone is there. If you take open source like FISS is there, ChromaDB is there, and if you take Neo4j, Neo4j is a very new concept. We have a vector on top of GraphQL, graph database. So there are lots of vector databases are there. So you can use any vector database. I feel MongoDB is very user friendly. You can just go and start using it. So I used to store it in MongoDB vector database. Right? PG vector. Okay. So again, the user is going to ask some doubt. Okay, that is going to convert into vector. That vector is going to be searched on, that is cosine similarity. We are going to see the similarity from the database, and 2 chunks will be returned. Suppose if the user is asking any doubt from the image, this 2 chunk, at least 1 chunk will have the caption of the image along with the URL, that is the image URL, right? So we are going to send the chunks plus image plus user query to AI model. So we are going to send all those things to a AI model, and we are going to get the final result. So this is what the steps is. I will show a demo. So maybe I can again show some steps. So step 1 is converting PDF to Azure Document Intelligence and getting the markdown, and the next thing is converting each and every page into a separate image, and third step is cropping the image from the page, and fourth step is giving that image to an AI model to get the caption, and fifth step is replacing the figure tag with the original figure URLs, and next thing is chunk all this data into small chunks, vectorize the chunk, store it in database. This is the first step. First step is over. The last step is we need to use the query over there. Okay, so I will show a demo. For this demo, I'm going to take this document. This is a kind of a research document which has lots of content, tables, and some images. Okay, so what I'm going to do is I will just quickly walk through the code. So usually everyone used to do it with Python, but I'm a Node.js fan, so I will do it in Node.js, right? Okay, so I'm going to tell the image and convert that PDF into a base 64 format, and I am initiating the document, that is Azure Document Intelligence here with the Azure API key, and here is the process starts, that is converting that PDF into markdown. Okay, so this is how we are getting the response. Okay, so in this variable we will be getting the response. The response will look something like this, output.json. Okay, so see here. So if you see, this is the markdown content. Okay, so you can see that figure tags over there. So this is returned by Azure. I will just go down and okay, so we have all the information about how many pages are there, how many tables are there, how many paragraphs are there, how many sections, and how many figures are there. If you see figure, you will be having ID of that figure, bounding box. You can see the polygon over. This polygon is nothing but where the x and y coordinates of that particular image. This polygon is used to crop that image from that PDF. Okay, so here's what I'm converting the PDF to pages. I'm just converting it to pages. This will be like, see here, each and every page is saved as a separate image. So I'm also drawing a bounding box on the image with the polygon information. Now, okay, now we are going to draw the bounding box and crop the image. See, this is how we are drawing the bounding box, and next step is cropping the image. So we will be cropping the image from each and every page based on the polygon information. This is a long loop which is running on each and every iteration. It will be cropping each and every page, right? And understand image. Understand image is the important thing. We'll go into this function. So understand image is nothing but I'm using AWS Bedrock as a service. So in that I'm using a model called Claude 3 Sonnet. So this is the model which I'm using. So I'm sending this image to Claude 3 Sonnet and I'm asking for a so describe this image. Note it has an image caption. Describe this image. Okay. So what happens is that AI model will send a caption, that is a description of that particular selected image, and update the figure information. So here is what we are doing, some kind of a regular expression kind of thing to update that figure URL. So once this is done, we are splitting the characters. We are splitting the characters based on the thing, and I am chunking the overall markdown file into small documents. I'm using a framework called the LangChain. So LangChain has a concept called a document. So this new document is coming from LangChain. So for the page content, I can use some metadata. So inside that metadata, I can say that this is the image URL, this is the ID, and this is the file name. So this document will be vectorized and stored in MongoDB as a MongoDB document. Okay, so and finally I'm going to vectorize. Vectorize is nothing but, again I'm using OpenAI's embedding, that is text embedding 3 small model I'm using to convert that chunks into a vector. And finally I am creating a MongoDB Atlas vector search. I am mentioning the collection, MongoDB vector index name, and finally I am adding the documents. So this is where the LangChain's MongoDB vector will convert each and every chunk into a vector and store it in vector database. Okay, and finally close the connection. So this is the first step. First step has been done. Now let's come to the second part, that is searching. Okay, so this is a normal API where I am connecting to the MongoDB and fetching the collection, and I'm using that same OpenAI embedding. Here, this is what we need to understand. You should not use different embedding models for vectorizing and searching. You need to use the same model. I'm using the same model, and finally I am searching it. Okay, searching it, and I am getting the question from the API request, and this is called similarity search. Similarity search means like the question is converted into vector, and we have a large vector. We will find the similarity, and it will return the 5 documents. Using that 5 documents, I am using again the same AWS Bedrock service, that is a Claude model, to get the final result. So here I am sending that image as a buffer, and the same content which is returned by MongoDB, and finally, say I'm using the same Claude Sonnet, and so I'm giving a prompt, and finally we are getting a result. So this is the overall process, and I can use Postman tool. Okay, so what is the difference between lenticular vector and AAV? So if you see this document, we will be having some kind of the difference between this lenticular vector and AAV in the image. So if I send the request, I want to start the server. Again, I'm a big fan of Bun.js. How many of you know about Bun.js? Yeah, okay. So Bun FN vector sets yes. So this should give the result. Yeah, if the result have some images, then that URL of the image will be returned from the vector database. Okay, so this question doesn't have image. Let me ask some question which has image. Let me check this. What is lenticular vector? So see here, this question uh, can be answered using an image. Okay, this question is inside that image. So automatically, based on the similarity search, we are getting the URL of the image as well as the content. So now you can just display the image and you can show the content in below, so that the user will know that this question is answered from the image, right? So this is thing, and even from the tables, for example, see here, when did TTR released, it is got approved. So if you see the table here, we have a table, and here some disease are there. So they are finding some generic name, and there are some years mentioned here. So I'm asking, like, when did this particular TTR related hierarchy has been approved? Okay, so this is the question I'm asking. So it should understand the table. From the table, it will fetch the result, and it should say that. So see here, 2022, and there is another thing called in 2023. Okay, so this is what it is returning, and now what I can do is we can write a HTML, and what is lenticular vector? This is what this is the question which come with the image, right? So image, submit. So see here, so we got an image as a result, and below that it will give the explanation from that particular caption and the text which is inside the document, right? Okay.
So the table is also stored as an image?
Sometimes table, if the table structure is very small, it will be converted into Markdown itself. If the table structure is complex, then it will also convert into figure. So it will be like mapped over there. So we saw about
pictures are it's operating entirely on the caption and
yes,
understanding about the picture.
yes, yes,
and that is what gets stored in the
vector. So whenever you ask a question, this captions should have that information. So whenever you are generating the image as a caption, please make sure that you need to create a detailed caption of that particular image.
and that caption ingestion is happening in the Azure.
Not Azure, it's happening in Claude. From image, it is going into Claude model, and captions are coming.
Azure is only doing OCR.
Yeah, Azure is only doing OCR. Yes. Actually, Azure has this even MongoDB vector search, right? Azure is also having that service, and in AWS there is something called knowledge base. I think they are using Pinecone behind the scenes. They are also having, but I don't want to go on vendor lock with Azure or AWS or thing. I like to be in the open source or a free version kind of a thing. So I will use everything. I will use OpenAI, AWS, Azure, MongoDB. I will use the best things and I will build my own solution.
So using this document intelligence, you are able to extract the image
Content into markdown file.
markup
Yeah.
and then crop the images also out to send to.
Send. Everything is manual process. See, in this 8 steps, in first step we have a AI. Azure Document Intelligence, it's a AI service which is provided by Azure. In second step, there is no AI. In third step, there is no AI. In fourth step, we are AI. We have AI sending the image to AI model. In this step, there is no AI, only regular expression. And in this step, there is no AI. Here, there is no AI. Here also, there is no AI. And here, the AI comes. So in the whole process, in the 8 steps, we have AI in some places plus manual automation. So combining all together, we need to provide a final solution for the end user. It should look like a magic. Okay, but what everyone says, AI is doing this, but actually AI is not doing this. As a developer, we need to understand the process, split everything into properly, and we need to build a solution on top of this. Yeah. Just for our understanding, whether the document intelligence has been identified the image correctly or not, or any kind of overlapping or this thing has happened or not. So that's just for understanding.
Yeah, I have a couple of questions. So we are inserting the document into the vector.
Vector.
So again, when you are passing user code, this chunk one, chunk two, we are fetching from the
Vector database.
vector database.
Yes.
So this is passing as a vector database or actual chunks.
Actually, whenever you are storing the data as a vector, you will be storing the vector and the equivalent text. Yeah. Whenever the system is searching, it will search in vectors. Whenever result is coming, it will come as text.
So retrieval will retrieve.
The original text.
Okay. So here, when you are passing the chunk along with your user code is element
You mentioned what is lintel.
So when the user query you mentioned, right, it will go to again invite.
Yes.
It will retrieve the based on the user query, it will retrieve the chunks. Right?
Yeah, the user query will be again converted into vector, that is numbers,
Correct.
using the embedding model. It will go to MongoDB search. It will find the similarity.
It will fetch the vector.
Fetch the two chunks.
The chunk has a data or vector.
Both.
Okay.
Both. I can show that. If I think I didn't log in that. So this MongoDB Atlas, right? Only Atlas have this functionality to do a vector search. So there is a database and I am browsing the collection, and inside that collection I am having the database. And if you see each and every document, you will be having 2 to 3 fields. Can you see there is a key called embedding as well as text. If you open this embedding, you can see only numbers. Okay, so this is where it is searching the similarity. But once the similarity is identified, this whole document will be returned. So we will be using this text. This is the text which is chunked into. Sorry.
Okay, here we have multiple embedded values.
Yes.
If user query matches with any one of the values, it will return the entire document.
Entire document. We will be using the text as a source. We will be omitting that embedding.
So in this case, security is a concern, right? We are exposing our data into the.
No, see, here everything can be replaced with open source. I will come to that point. What are the open source thing? Only I am searching open source equivalent to Azure. This is the only thing where I cannot find a perfect open source. Wait,
Step. So
wait.
you enter a user code.
Hmm.
It will identify the related chunks, right?
Yes.
Related chunks. We are passing into LLM model.
Hmm.
In this case, what LLM we are using?
We are using Claude Sonnet.
Parts, right? Okay. We are using LLM. So we are exposing our data into
No, it can be replaced with open source LLM models. There is something called Llama 3. You can use Llama 3.
So again, we are exposing.
No, Llama 3 can be installed in your local machine.
Okay.
You can install it in your local machine and send that data into model, and you can extract the data. That model will not have a, without internet connection also that model will work. Okay. So here I'm for finding a best open source for this. This you can use Llama. This you can use ChromaDB or FISS equivalent to that. For this vector, again you can use Llama embedding thing, which is again open source. And here also it is open source. Like okay, document intelligence also we have lots of open source packages over there. But again, the accuracy and the structure which it going to return, right? We need to test that in multiple documents, and we need to make sure that this will fit for our document or not. That's the only, yeah. Huh? Okay. Text. Okay, based on their coordinates. I will explore that. We need to try it with different things. Yes.
What if we have formulas in the video?
Uh,
Still Clark can convert it into caption plus.
See, actually, what is formula is? Formula is nothing but it's a something called a latex. Latex. I don't know what is that. Latex caption or something like that. So whenever I have not tried it, but whenever this Azure Document Intelligence returns, either it can consider it as an image. Better consider it as an image. Don't convert it to text. Crop that particular formula part alone and give it to AI model. It will take care. Instead of sending it in as a text, image is a better solution to send that.
What about like flowcharts? Because
Convert into image and send it. Anything is which is complex, better convert into thing. Even if you have a language, suppose you have a paragraph in French, which embedding is not working properly, then convert into image. So, any questions?
Yeah, the document intelligence.
Okay.
The document intelligence, how accurate?
The document intelligence.
The document intelligence, the first step, Azure service you're using. So how accurate is that? Like,
As far as I tested with a few documents, it is accurate. But we need to test it with multiple things. As per the meetup which I attended in Bangalore, they are promoting it very heavily. Azure is doing that. I think it will be a nice thing.
okay.
We'll test it. Yeah.
I think the magic is in the markdown.
Yes. Markdown is the final file format which we are getting. Okay. Yeah.
So this is also called VQA, right? VQA.
DQ.
VQA. Something I read. I just wanted to.
Okay.
Visual Query Analytics something.
This is when tested with any document that has a single table, but it has multiple pages.
This document is having, right? This document. See, this document has split into multiple tables. Actually, yes, there is. This document will be split into multiple chunks when it comes to this thing. That will also understand. See, the only thing is when you are converting into caption, you need to make sure that captions are large enough to explain the data. It should not be a one-line caption or two-line caption. It should, as much as possible, you need to explain that data.
I think the
Yeah.
Different table.
Oh, table one, table.
Last thing is same table spread over multiple pages.
Because in step 1 or 2, we are splitting the multi-page into a single page image. In the step itself, the single table will be split into multiple tables, multiple pages. So there may be a data loss because of chunking.
Okay, in that scenario, better use the text itself as a, don't convert into image. whenever you are converting into image, then you can have a data loss. But whenever you are converting into text, then it will retain the information. See, either you can take a decision whether to maintain it as a text or this thing. What is that? Image. So if you see this output.json, so you have include the text will also be there, and the figure will also be there for a table. Okay, so see, there is a table information. In this array, you will be having a table information. At the same time, the content of this table will be present in the markdown itself. So either you need to take a decision whether I am going to use a text or I am going to convert the table into image. Yeah, okay. Any questions? Okay.
How about scaling? Meaning, you are doing it for one document now, but we'll be having like thousands of documents.
See, if you are going to do that in a local system on-prem, then scaling and this thing is a challenge. You need to scale the hardware. But if you are doing that in a cloud, there are many solutions in cloud, in Azure or in AWS or in Google Cloud. So you can trigger a separate Lambda functions or a separate function for each and every document to scale it. So at the time, if I drag and drop 500 documents, 500 documents will parallelly convert it and it will be stored. And when you're searching, again, you need to increase the database size to get the final result.
You can put all documents in the same vector DB, so
Yes.
that you can search across various PDF.
Yeah, so whenever you are generating, you need to generate a unique ID of each and every document, so that whenever you are searching, you can say that in this particular document ID, go and search the vector. Don't search in all the 500 documents. This is what you can mention it.
Is there any restriction in the vector DB, like we can show only this much amount of data?
Yes, there is something called again this context, and if you see in database, can you see this 1536? This embedding 1536. This 1536 is a restricted dimension of that vector. I talked about the dimension, right? 300 dimension, 500 dimension. This MongoDB has this 1536 or 1024 as a dimension. If you have built a LLM model, whenever we are generating an image, you can see that the image will be generated only in a square shape, 512 or 512 by 512 or 1024 by 1024. It will be in even number and it will be in square shape. You cannot generate an image in AI model in 16:9 ratio. That is 1920 into 1080. Why? Because when you train the LLM model in the mathematics, there is a restriction for that. The context window, that restriction is there in all the LLM models. It follows everywhere.
Is there a way to find out what is the size which database for your use case for this PDF? So what is the size graph DB, means vector DB occupied for this PDF?
No, see, according to MongoDB, each and every document can be 16 MB size. But I don't know how much memory this particular document has occupied. Maybe we can run some query or something like that. I don't know that. But that is difficult to identify.
The reason is for extending his question, when we are scaling up, right, if we go with 1000 or 5000 documents, we need to know the size.
See, whenever you handle with size or scalability, the only thing is you need to expand the hardware. There is no other.
It will occupy at least the size of the documents, because all the text is going in anyway, and then there is embeddings and some other methods. You can assume that if you have like 100 documents of 10 MB each, then 100 times 1000 MB is used for a minimum.
No, I'm just curious to know.
Yeah.
Is there a way to identify that?
I think it is a little bit tricky.
In FYS is something they are attacking.
Yeah.
Pure vector DB. Maybe they are having that kind of something. Just they try to.
But 1536 is a dimension, right?
Yeah, dimension.
So when you're querying, when you were querying in Postman, right? I saw the latency was like 8 seconds.
Yes.
What's the cause of that?
That's because it is going to MongoDB in the internet, and the AI models also I'm using AWS, right? So all these things are connecting to internet. That's the reason it is latency. But if you have everything in your local system, then it will be very fast.
And the vector search, like, I'm guessing like it multiplies your query vector with all the vectors inside the database, right?
Yes.
So if you have more files, then your latency will increase there as well.
Again, we have options to scale this MongoDB Atlas, but in local system, you need to expand this.
Oh, so I'm asking, like, let's say you have 10 documents. So do you do your query vector times all the 10 documents? So you have 10
It
queries.
is
Yeah, you can-
cosine similarity, no?
Yeah.
It doesn't. The time doesn't increase with the size of your number of records in your.
But for cosine similarity, you still have to compare the query vector with all the vectors in your database.
No, you can. There is something called ID, right? Sorry, there is something called why it is. There's something called ID.
Yeah.
So whenever you are searching, right, you can pass the ID so that it will search only in that particular document.
Oh, okay. So that you can filter.
Filter out, yes.
Okay. But it will still, it will still increase with the, like, if you have, even if you filter and you filter like only, let's say, 100 documents.
Yes.
So you'll still have to compare with all the 100 documents.
Yes. But since it's a mathematical operation, that will be very fast. It's not like an image processing or something like that.
Right. But
Since
it's still like ON.
Yeah, yes. It's a dot product of matrix, right? Two matrices are multiplied and it is finding the cosine similarity.
Makes sense.
Yeah, okay. Any questions? We'll wind up. Yeah, okay. Thank you.